Hey, this is Mr. Hansen. Today we're going to look at creating some parallel lines if you have a little bit of given information, namely a point and a line. So, I don't know, this came in handy years and years ago when I used to have to paint football fields, and I needed parallel lines to do that. And so if I had a line and then I had a point somewhere right there that's maybe 5 yards away from that line, I had to draw another parallel line. So that's maybe one example of when this might come in handy. And there are two ways to do it. So let's look at the first way. The first way involves a coordinate plane, and it involves equations of lines and that kind of stuff. And this is good. Good to know how to do it this way. So let's go ahead. I've graphed this point y equals 2x plus 1. You can kind of see I have a slope of 2 here. And then I've got this point 3, 4 right there. So I need a line parallel to that first line going through that point. So one thing you might remember about parallel lines is they have the same slope. So I know that my line, and I'm going to do my line in, let's do it in green. I'm going to go y equals 2x plus b. Okay. I know my b is going to, and I can even kind of highlight it right now, kind of like this, okay? So I know my y-intercept isn't going to be 1 like the first one, but I do know I can borrow the slope of 2, okay? Because there's parallel lines, they have the same slope. So all I have to do is solve for b. And there are a couple of ways to do this. Let's just do it one way. Let's plug in 3 for x and 4 for y. So 4 equals 2 times 3 plus b. And that's 4 equals 6 plus b. And subtract 6, and we've got b equals negative 2. Okay, b equals negative 2. So we got y equals 2x minus 2. And that's your answer right there. So that's one kind of quick, easy way. If you're comfortable with slope-intercept form, that works pretty good. The other way is to write it in point-slope form. And I don't expect you to memorize both these ways, but you do have to know how to do this. So point-slope form, I'll do this in red over here. It's m times x minus x equals y minus y. If you haven't seen that before, just divide both sides by x minus x and you have the slope formula. So our slope was 2, and then we have x minus 3, because this is my x here, equals y minus 4. That's my y there. And then we just distribute and add 4 to both sides, and we'll end up with the same thing. So 2x minus 6 equals y minus 4. Add 4 to both sides, and we get 2x minus 2 equals y. Okay, same thing. Whether you use the point-slope form in red or the slope-intercept form in green, it doesn't matter. But be familiar with how that works. Okay, let's take a look at the other way to find a line that's parallel to a line going through a point. So this way is a construction, and so I need to give you one piece of background information on the constructions. We're going to learn how to copy an angle. So let me draw my angle out. I've got an angle that looks something like that. And so if I want to copy that opening right there, what I can do is my first step, I'll do it in red, is to make a ray. So you can kind of see that these two rays, same thing. Rays are always congruent because they're the same length. They go on and on forever. Okay, next step, and if I had a compass, this would look a lot better, but I'm going to kind of freehand sketch it. I'd like you to use a compass. If you have one, it works a lot better, or some computer software. But let's do this. I'm going to make a part of a circle, an arc. There's the center. I'm going to go like that. Okay. And again, if I had a compass, it would be a little more realistic, but I think you get the idea there. And then I keep my compass setting. So basically I'm copying a radius. I'm copying a radius. And so I'm going to go right here with my compass setting. And I'm going to go kind of like that. And hopefully, it's not quite right. Let's try it again. Okay, something like that. And so if I did that right, then the distance from the vertex to that first point is going to be the same there as it is there. Okay. And then the second thing I do, I'd open my compass up so that I've got this length from the red point to the red point. And you know, you could make a circle around that red point like that. You don't have to. But then I keep that compass the same setting, and I've got the same length there, and so I don't have that point yet. But I measure this, and then I kind of make an arc. It goes something like that, maybe. And then where these two intersect right there, we're just going to kind of finish off my last part of my angle like that. And obviously mine is not perfect because the angle actually even looks a little bigger than the other one. But if I did this with a compass, I think it would be just fine. So just a reminder, make your arc. I'm just going to highlight this, make your arc. And then make a circle around the center of your first angle. And then make that same circle, the same setting right there. And then measure with your compass, measure these 2 points right there, and then measure, so you know this one right here. And then you just measure that distance, that keep the compass setting from that one, bring it over here, and you have that new point, and then you've got. Okay, so that's kind of how you copy an angle. All right, hopefully that's helpful enough for you to do what we need to do next. We are going to create two parallel lines given a point and a line. So there's my line, there's my point. Okay, first step's rather simple. I just draw a transversal. Transversal cuts through a line, and it's going to cut through that point that we have there too. So something like that, transversal. I'm going to make this point actually go through it right there. Oops, let's try it again. Let's just start with the point right there, and let's go red line, something like that, and let's clean up the mess. Okay, so there we have it. We have a point and a line, and we made a transversal. Now, you'll notice that we've made an angle with the red line and the black line. So we're going to copy that angle. The vertex of our new angle is going to be right where the point is. Okay. And so we go ahead and we make a little arc here, or you can make a complete circle if you wanted to. And then we make a congruent arc or congruent part of a circle right there like that. Something like that. And we kind of highlight this point right here. Oops, well, we'll just do it that way. And then we measure this piece right here from there to there, and you can kind of think of that as maybe another angle or another circle. And we do the same thing here. And oops, I messed up on that. This would probably be a lot better if I showed you with a compass, but I'm not too good at that. So we want the center right here. We've got this compass opening right here. So we make this the center, and we kind of go like this, something like that. And then this point here is our new point, and then we can make the line with those 2 points just like that. So basically we've copied that angle right up there, and by copying those 2 angles, we know these 2 angles are congruent. And if you have a pair of lines that are cut by transversal and the angles are congruent, you might remember that the lines have to be parallel. It's the converse of the corresponding angles theorem. So that's the second way to prove, or to kind of make that second parallel line, a line that's parallel to the first going through a given point. The first way involved using a coordinate plane and using an equation and a point labeled with an ordered pair to find a second equation. I hope this helps you out in some way. Thank you very much for tuning in. This is Mr. Hansen. I'm signing out. Thanks.